So for velocity graphs, a couple of important things to know about velocity graphs are what's really on the axis. So we know on our x-axis is time, and then on our y-axis is our velocity, which is typically measured in meters per second. Something that's important about a velocity graph is this zero right here. That zero has a very different meaning on a velocity graph than it does in a position graph. It means zero velocity or an object being at rest. So it is not an origin in this case. That's different than like a math term. So this zero right here in a velocity graph means that the object is not moving or it's at rest. The zero velocity. That's very different than an origin, let's say on a position graph that I have drawn over here. The zero position is the origin, right? The zero position is the origin. So that point is actually the zero position of the origin. Okay, so you're asked in this question to draw the velocity graph for an object that moves away from the origin at a constant speed. Now, I've drawn the position graph to help us think through this a little bit. So the position graph might look something like this. Positive slope, linear graph. And what we need to ask ourselves is we need to ask ourselves about the slope. What does it look like? Well, first of all, the slope is positive and the slope is constant, meaning it's a straight line, it's not curved. So that means the velocity graph might look something like this. Notice that the velocity graph is horizontal, meaning that the velocity value stays the same over time, which matches this idea of a constant velocity. Also notice that the velocity is on the top half of that velocity graph. That's because the slope of our position graph is positive, or it's sloping up. That indicates that the object is moving away from the origin. If we change the slope, so let's say we had an object that was going a little bit slower than that blue line. So let's say it is moving something like this. So that would be slower than the blue line. The velocity graph for that would be, again, a horizontal line, but it would be lower on the velocity axis. So it might look something like that. If we have an object that is traveling toward the origin, so in this example, we're going to look at an object that's moving towards the origin. Again, on our position graph, our 0 meter location is the origin. We would have a position graph that looks like this. In order to draw the velocity graph, you need to think about the slope of the position graph. The slope of this graph is negative and it's constant. So when we come over to our velocity graph, we are going to draw our velocity on the bottom half, or so that it has negative values on the velocity graph. So what's really important to know and understand is the different parts or the different halves of our velocity graph. If you have a velocity graph that is on the top half, let me get just a different color here. So any part of the velocity graph that's on the top half up here, this indicates the object is moving away from the origin. If we have a velocity graph that is on the bottom half down here, this is going to indicate that the object is going towards the origin. And again, that's because of the slope of the position graph. We can also draw velocity graphs numerically. So that's using actual calculations to calculate slope. So one example would be this one here. And we see the object is moving away from the origin at a constant speed. So we know it's going to be a horizontal line somewhere over here on the velocity graph. But now we have a little bit more information than that. So we're going to erase that line because we know that we have a scale on our axes. So notice that we can calculate the slope. Again, you can do rise over run, or you can do change in position over change in time. And in this case, our change in position is 1 meter in 2 seconds. So we would have a slope of 1/2 meter per second. Another example would be one that looks like this. Now, notice we have 2 parts to this graph. We have a negative slope for the first 3 seconds. So our object is traveling toward the origin, again at a constant speed. So if we take our 2 points here, we see that we have a decrease in position of 3 meters. So it goes 3 meters down. That's why that's negative, right? Because the slope is down in 3 seconds. So our velocity is negative 1 meter per second for the first 3 seconds. Then for the next 3 seconds, we see that the object is not changing position, that the object is staying in one place. So for these final 3 seconds, the object is staying in one place. So that means our velocity is 0. So we draw our velocity up here on the 0 velocity axis. Don't worry about connecting those two different parts to the graph because they are just two distinct or separate parts. So just draw each segment and don't worry about connecting them. So we have a constant negative velocity for those first 3 seconds. And then when the object's position is not changing, we have a velocity of 0 for those last 2 seconds.